check. Right. Good evening, everybody. Welcome to the 7th and final session on STL Standard Library Containers and Algorithms. It's been a longer module than, I think it's our longest so far, actually. We did have Christmas in the middle, which sort of confused things a bit. But yes, here we are. We've reached the end. First of all, before we start, just my standard slide about feedback and everything. Please join our Slack channel if you haven't already. Go to that URL, pop your email address in. It'll send you an invitation to come and join us, so you can chat to us in our chat room on our channel. So please go and do that for those who haven't already. So last week we talked about algorithmic complexity. We had this sort of bit of an aside for an hour or so, talking about big O notation, what it means in sort of broad mathematical terms. We didn't really go into too much of the kind of computer sciencey depths of it. And then we looked at how the standard algorithms are actually written. They're function templates that get specialized for the particular types that you use with them. And this is what allows them to be so efficient. So this week, we're going to have a bit of an overview of some of the standard library algorithms. And then, so that's going to be about half of the session. And then the second half, we are going to have a little quiz, a little questionnaire. Those who have been with us for a while will be familiar with these when we reach the end of the module. Nothing to be worried about. It's mostly just so I can know whether my teaching's been any good. So yes, that's what's on the menu for today. I did leave you with an exercise last week. Unfortunately, we didn't really have time to do too much of it in class, but I left it for those who wanted to do it. And your task there was to implement some of the simpler standard algorithms. So I set you up with some code that had all the boilerplate in there, the function templates and so on, but didn't have the implementations. So who did that? Only 3 of you. Okay. Well, I think that this is a pretty good exercise to do, to get an understanding of how the standard library algorithms actually work. None of the things I've told you to are all that complicated. It's just a matter of sort of thinking about it in terms of iterators and thinking, how do I do this in kind of a general way? Right, so the solution is available. It's on GitHub. That URL there. If you go to the problem page, there's a little drop down. You can select the solution branch, which has my solutions. I'd really recommend, for those of you who haven't done it, you go back and you have another look at it, because I do think it's a pretty good exercise for really getting a good idea of how these things actually work. So I won't go through the solutions now, but as I say, they are online, and so if you want to have a go at it, I'd really recommend it, and then you can check your answers against mine. For the 3 of you who did do the homework, do you have any questions about it? Anything that stumped you? Or was it all pretty straightforward?
It was, yeah. I still don't quite understand when would be like an appropriate moment to use them, but I suppose that will just happen when we do it more, I guess.
When is an appropriate time to use one of the standard algorithms? Really?
Like the template specifically.
Oh, the template specifically.
Yeah.
Yeah, that's quite a good question. And there's no sort of one answer that you can always give. In general, when you have some code that you find you're repeating a lot, possibly with different types, you're doing a find in a vector, and you're doing a find in a list, and you're doing a find in some other data structure, well, you can sort of lift that code into a generic algorithm, right?
Yeah, I was thinking something along that lines, like if you say had to search for a lot of things and you needed to use a lot of filters, would that be sort of...
Yeah, that might be one way of doing it. Kind of setting up, perhaps you would call one of the standard algorithms, but you'd do a bunch of setup code for yourself first. And that might be an appropriate thing to put in template. There's really no hard and fast rule. I find the more, as I've got into doing C++ more and more, as I've gone on, I tend to write more templates, but that's also one of the things people criticise about C++ is everybody's trying to be overly generic all the time. And sometimes simpler code is better. So, yeah, there's no hard and fast rule and no sort of one definitive piece of advice I can give you on that, I'm afraid.
Yeah, so it's not quite one of the ones you gave us, but we have to compare for equals.
Mm-hmm.
We have different type names, so like an int and a float.
Yeah.
And they're both 1.0 or 1 and
1.0, yeah.
That's quite difficult, does it?
It's no, because you can compare those. In the C++ language, you're allowed to compare an int with a float, and what it will do is it will promote the int to a floating point value, and then compare the floats.
It didn't work when I tried that in a template.
If you have like an iterator representing an int, an iterator that when dereferenced gives you an int, an iterator that when dereferenced gives you a float, you just do start it 1 equals start it 2. That should work.
Okay, I'll have another look at it.
There's also, as we'll see very shortly, a standard library function object called standard equal, or standard equals, or standard equal to, that's the one, which actually does this in a kind of generic way, lets you compare two objects which are comparable. Okay, so let's crack on. Let's have a little, a very brief, in fact, overview of some of the standard library algorithms. There are, depending on how you count them, somewhere between 90 and 105 different algorithms, different function templates that you can use in the standard library, and that you should use. Because it makes your code shorter, it makes your code clearer. The standard library versions are going to be highly efficient, are going to be debugged, and it means that everyone else who's reading your code can just see, oh, well, you're doing a find here. Oh, you're doing a count. They don't have to look at the for loop and try and work out what this for loop is doing. You don't have to bother writing a comment. You can just see it's got standard find in there. Oh, well, I'm searching for a particular element in the set. Right, the standard library algorithms are brilliant. They're the best thing in the standard library, and you should use them. And there are lots and lots and lots of them. As I say, between 90 and 100, depending on which ones you count. I can't possibly go over every single algorithm in detail and give you, usage examples for all of them. That would take far longer than we have. So what I'm going to do today is to give you a sort of rapid fire tour over some of them I find most useful, and show you a couple of tricks that you can do with these, and show you a couple of common, what we call idioms, common patterns that you can use with some of these algorithms. If you want something a bit more in depth, CPP reference, which I talk about every week, but cppreference.com. Each and every algorithm has its own page on there. It'll tell you all the details you could ever wish to know, probably more than you could ever wish to know about all of them. And for most of them, it also has some nice usage examples. And again, in some cases, it shows you some quite clever things that you can do with them that you might not have occurred to you. There's also this video on YouTube. I think it's from CPPCon, I'm not really sure. So from a conference anyway. It's a guy called Jonathan Bakara who runs a CPP blog and also does conference talks, obviously. And he has this talk that goes over 105 STL algorithms in less than an hour. Now, needless to say, he doesn't go into them all in detail either, but he does a pretty good overview. And if only we could have him come here and do this, I wouldn't need. But it's a really good talk, and if you've got an hour to spare or less than that, if you put it on faster speed, I recommend going to watch that. going and watching that video.
Ask him to wrap it.
Wrap it? Well, maybe. I'm not sure if he's a rapper, but there we go. There's also, I mentioned this last week, another video is C++ seasoning by a guy called Sean Parent, which is also another really excellent video. And he, slightly different approach, but he takes some sort of really complicated, gnarly looking code from, I think it was from the Chrome browser, and he sort of goes through a process of really simplifying this code until it ends up with just a call to one of the standard library algorithms. It really shows off kind of the power of these facilities that we have at our fingertips, and yeah, it's a really good, really influential talk. So again, if you've got some time to spare, if you're on the bus on the way home tonight or something like that, pop in your headphones, look these videos up on YouTube.
John Bocara he spent 57 seconds per algorithm.
57 seconds per algorithm. Right. Well, he also had an introduction and a few questions at the end. So yeah. Okay. So let's start off by talking about some of the simpler algorithms. As I say, I'm not going to go into all of them, and I'm not going to go in massive depth. But these are just some of the ones that might not occur to you to use, but that I use fairly frequently and that I find pretty useful. Right. So first of all, we've got these three of them there, a little family. They're all of, any of, and none of. Oops. And these functions, all of them, they operate on a range. All of the standard library algorithms operate on a range, that is from begin but not up to including end, as you're all familiar with by now, hopefully, if you've been following this for the past 6 weeks. Except a range of elements, pair of iterators denoting a range, and a unary predicate, that is a function that takes one argument and returns a bool. We talked about predicates last week. If you want, you can go and add to the list of videos this talk from last week if you didn't see it. Or we went over predicates and how to use them. So all of, any of, and none of, I think a range of elements and a predicate, something that is true or false. And it applies this predicate, it runs this function for each element in the range and returns true if either all of the elements satisfy the predicate, if any of the elements satisfy it, or if none of the elements satisfy it. This seems like quite a simple thing, but these three functions, I actually find them quite useful. I find I use them quite often. Right, really simple things. You could write them yourself in a little for loop, but you don't have to. Someone's done it already for you. And they're particularly useful. In fact, many of the standard library algorithms are particularly useful when they're combined with lambda functions, which is not. We touched on it last week. We haven't really gone into detail about what lambdas are and how you write them. We will do that, but just bear in mind for now that you can use these things called lambdas. A lambda's kind of like a way of writing a function in line, right? So you don't have to write it separately outside of where you are. So many languages have lambdas, including C++. So yeah, we'll go into a bit more detail about lambdas in a future session, but for now you can just keep it in the back of your mind. Let's just have a little example of how you would use these. Start off, just got a vector of 5 integers, 1, 2, 3, 4, 5. And we've got this function called less than 10, which returns true if, given an integer, it returns true if that integer is less than 10. Right? Pretty simple. So this function is a predicate. It's a predicate that a unary predicate that takes an int and returns a bool. Which means we can use this with any of those three functions I was just talking about. In particular, start off with, we can call standard all of, and we pass it the beginning of the vector, the end of the vector, and the predicate that we want to apply. And what this will do is it will call this less than 10 function, it will call it with 1, with 2, with 3, with 4, and with 5. And in each case, the predicate is going to return true because all of those numbers are less than 10. So because all of those numbers are less than 10, all of is going to return true. So our assert is going to pass. Something else we can do, so we can use any of, and this time I'm using a lambda function. So we introduce a lambda with these square brackets, with the argument type in brackets, parameter as we normally do for a function in brackets, and then the body. And in this case, our predicate, our lambda, returns true if the given value is equal to 3. So here, standard any of is going to go through the whole vector and see if any of them are equal to 3. In fact, it's not going to do that. It's going to test 1, it's going to test 2, it's going to get it up to as far as 3. It reaches 3, it's going to say, oh, okay, well, this is returned true. So now I know that one of my elements is true, so any of is going to return true because there is an element in here that is equal to 3. Finally, something a little different. Here we're declaring a function called is lowercase. We're taking a reference to a string, and we're returning a bool. So we return true if the string is lowercase and false otherwise. So just perhaps in your heads, think about how, if I'd given you this function to write as homework weeks ago, how you might write that. Can anybody just very briefly think off the top of the head how they might do it?
First element. You check the first element of the string.
Check.
The 0th element.
Check the 0th element is lowercase. Well, we want to return true if every character in the string is lowercase. Yeah. So you just iterate over the string, and if any of them is not lowercase, return false. So what we really want to do is make sure that none of them are uppercase, right? That's kind of what we're doing. None of the elements are uppercase. So we can do it really simply, just like this. We call standard none of. We pass the beginning and the end of the string, that's our range of characters. And we call this C library function, in fact, called isUpper, or isUpper, if you prefer, because it looks like it to me.
Why is it just scope resolution in the beginning?
Yeah, it's because this is part of the C standard library, not C++ standard library. And you could put standard isUpper in there, but then you're going to get a conflict because there's also a C++ standard library function called isUpper, and it gets a bit confused because then you've got two functions.
Well, why not use the C++ one, or is it a different?
Yes, because the C++ one takes a locale as well, right? It worries about whether you're
Locale.
a locale. It worries about whether you're using English or German or Swedish or Swahili or whatever. Whereas isUpper only cares about ASCII, like really basic character set.
So if you just use scope operation, that will work.
So what this says is this function isUpper that doesn't belong to a namespace, or more properly, is in the global
Do I need
namespace.
to have any header for that?
Yes, this is in the, what header is it? C type, I think it is, TYPE.
Also, I should point out that this code is pretty well, that is pretty well lambasted online using isUpper, 2Upper, was it 2Upper? Stay away from C functions. If you're writing a toy program, nobody cares, but
isUpper checks for
What was the
isUpper checks whether...
it's a function that was written as if America was the only country in the world.
Yeah. Yeah, this is not going to deal with Unicode or anything like that, right? This is, as Ollie says, this is kind of a toy function. This isn't something you'd use in production. What I'm trying to demonstrate here is that we can implement this in basically one line just by using the standard library. Whereas again, had I asked you a few weeks ago to write a function is lowercase, you probably have gone and used a for loop yourself, and you might not even have known about this is upper function. So we can do this really nicely just in one line. So any of, all of, none of, little family of functions that do sort of variations on the same thing. I find them pretty useful. I use them quite a bit. They're very good for asserts. You just want to assert something is true in your code. Make sure you haven't made any mistakes. You can use one of these functions. They're not in 17, they will be in 20. If you want a nice context version that you can use today, somebody very smart might have written a library that has all these things in. So let's move on. Let's talk about searching. Searching within a sequence for either a value or for another sequence that's a subsequence of the first one. Searching for one element, searching for a range of elements inside another range. There are quite a few different algorithms that are related to this subject. The simplest of them is find. So given a sequence and a value, it finds the position of that value in the sequence, and if it doesn't find it, it returns the end iterator. Remember, the end is past the end, can't dereference it, it signals that we have passed the end of the sequence, it signals that it didn't find the value we were looking for. Find if is very similar, except that where find just takes a value, find if takes a predicate, a unary predicate, and if that returns true, then we consider that we have found the element. It finds the first element in the sequence that matches the predicate, for which the predicate returns true. Find, by the way, returns the first element which matches. I didn't mention that. Returns the first element which matches the value.
Doesn't return the iterator.
Returns an iterator to the first element that matches. Returns the position. Yeah.
So does find have any thing to do with position? So if I wanted to find all the occurrences of something, could I use find?
If you wanted to find all the occurrences of something, yes, you could use find repeatedly, right? So, so find returns you an iterator to the position, to the position where it was found, right? So you go, okay, I know that position, maybe I save that position somewhere, and then you can do find again, but instead of beginning from the beginning of the container, you can begin from just one after the position you've just found. That makes sense? So you're continually searching.
It's just the next one.
Yeah.
From the one you found previously.
Yeah. There's find if, and there's its brother find if not, which does pretty much exactly the same thing, except it reverses the predicate. It looks for the first element for which the predicate returns false. There are other ways you could do this. You could just use find if and wrap the predicate in some function that reverses it. But there's find if not, which saves you from having to do that. There's find first of. Now we're getting a little more complicated. So find first of takes a range. That's the thing you're searching in. And takes a second range of characters or of elements to search for. Right? And it looks to see whether any of the characters in the second range occur in the first range, in the big range.
So, if you get something from the first range, from the first character or whatever,
Yeah.
then you look in the second range to see if they exist.
The other way around, right? So what it basically does is it goes through the first range, which is the big range. It says, okay, I'm looking at element 0. Is element 0 equal to any of the elements in my second range, any of the search elements?
So element 0 needs to occur any of the elements on the second range. Range two.
right? And then if that's not true, then it moves on to looking at element 1 in range 1 and compares that to each of the things.
So he checks every element of range 1
Yeah, against every element of range 2.
against, so first element checks everything in range 2. Second element of range 1 checks all the elements
Yeah.
of range 2.
And if any of them at any point compare equal, then it returns an iterator to where you are in range 1.
Returns an iterator?
Yes, all of
We
these
found that.
all of these find functions return an iterator. That is, return you the position within the sequence at which it found that element. Or if it doesn't find it,
The first time they found that, it's in range
yeah, the first time it searches from the beginning, and as soon as it finds one, it stops there and returns you the iterator. So that's find first of. Takes two ranges. If any of the elements in range 2 match an element in range 1, it returns that element. Search does something slightly different. Again, it takes two ranges. But this time it looks for range 2 as a subsequence of range 1. So imagine you were using this, you had a large block of text, and you were looking for the first occurrence of the word hello in that block of text. Standard search would be an appropriate thing to use there, right? There are also, there's another overload of standard search which takes, it's a bit more complicated, but it takes what's called a searcher object. I haven't shown an example of it, but it's, yes?
What's the difference between this from your description? I don't quite understand the difference between search and first of.
Between find first of and search. Okay, search looks for all the elements in range 2 if they occur in that order in range 1, right? So does range 1 have a subsequence which is equal to range 2?
Right. So exact match.
An exact match for all of the characters in order.
So hello in hello world.
Hello in hello world, yes, you could use standard search.
So basically, excuse me, the other one is not necessarily an ordered search, but the other one is a search and ordered search.
They all search in order. They all search from the beginning of range 1.
What I'm saying, like if you had, say I had 1, 2, 3, 4 in the big range,
Yeah.
and I had 4, 1 in the next range,
Yes?
4 would be the first one I find.
No, you'd match on 1 first there.
That's
Right.
what I'm saying, it's
Yeah.
ordered, isn't it?
Yes. Yeah, and it would return you an iterator too.
So both the ranges can be the same size or different smaller?
For which,
The search.
for search, if both of the ranges are the same size, then they have to be equal, don't they? Because,
They don't have to be. It could be unequal, but you're just comparing everything to everything.
yeah. Well, all right. It's always going to return false unless they're both equal. That's the only way a subsequence of the same length can be a subsequence if it's
It could be
the
the
same.
same length, it could be different characters.
And then you would never match, correct?
Do they do like an optimization check? So if let's say the same length and let's say the first character doesn't match, so then it doesn't match.
Yeah, these all have clever optimizations that you may not necessarily think of to do if you were doing these things yourself. So in particular search, when you give it, remember we were talking about iterator characters, these all accept ranges of one of the basic iterator categories, either input or forward. But if you give them higher categories, if you give them random access, they're going to do more clever things. They're going to take advantage of that. Search in particular takes advantage of that. And the basic search is just a very simple algorithm, just it does basically a linear search for that subsequence. You can use these searcher objects as well that implement some very specific, very clever algorithms. There's a Bowyer-Moore, and I think the other one's Bowyer-Moore-Horspool. Bowyer-Moore, is it?
Yeah.
Bowyer-Moore. And they're very sophisticated algorithms, pretty specialised for. They're generic in that it will work with any data type, but they're particularly good for searching for a short string inside a very big string. Right? They were designed by these very clever people, Boyer and Moore and Horspool, and they're pretty specialised use, but it's there if you want it. So yes, search looks for the first occurrence of range 2 as a subsequence of range 1. And then we have this weirdly incongruously named find end, which does the same as search, except it finds the last occurrence of the subsequence. That is, instead of searching from the front, it basically searches from the back. Right? Why it's called find end and not search end, I have no idea, because it's doing search in reverse, effectively.
Find something at the end.
Sorry?
Search at the end. You find something at the end.
If it looks from the back rather than from the front.
Yeah, but he's finding something from the end. That's why it's
Yes, but this one's called search, and this is doing the same thing, but from the other way around. So I don't know why.
because
If one's called search and one is called find, I don't know.
There's one called find first, and maybe they don't use it.
Well, I find this more confusing. It should be called search end. It's not. It's called find end.
But
So
the
there.
one above is it's a bit different compared to the one below. Because I mean, if you read the description, it suits to name that search. It suits to name the one below.
I think it's the matter of the committee meetings, isn't it, really?
Yeah.
It makes no sense. Go to the committee.
Anyway,
Where they-
let's have some examples because that hopefully make it a bit more clear than the descriptions. We've got our string. Hello, C++ London Uni. Hello. 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 So we're going to call standard find. We're going to go from the beginning of the string to the end, and we're going to search for a space character. So what's standard find going to do? It's going to begin at the beginning of the string, and it's going to work its way up, and it's going to stop when it finds a space character. So it's going to stop there, and it's going to return us an iterator to this position, which is position 0, 1, 2, 3, 4, 5. So it's going to return us an iterator to position 5 in this string. Turns an iterator to the first space character.
Just to ask something. Shouldn't we have like a name of variable in front?
Oh yeah, yes. And just imagine it's like, auto it
Because at the
equals
moment
standard find.
it does return, but it's anonymous variable, yes?
Well, it returns something, and that return value is just thrown away. I didn't want to have to write auto it 1, auto it 2, but
Does that have to be a chart? Maybe a double unit string.
Has to be a chart.
has to be a chart. Has to match the element type of this sequence.
Yeah, because you're looking for a character. So
Yeah.
you're looking for a string, that's a string.
Okay. That was find. Now we're going to do find if. So again, we're going to use one of these, not very good, but good for demonstration purposes, C functions dealing with ASCII strings. There's a function called isPunct, which returns true if it's one of whatever there are, about 10 different punctuation marks. So it's going to go through the sequence and it's going to check whether every character is a punctuation, is a punctuation character. So it's going to begin at the beginning of the string. Is H punctuation? No, 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 no. Space is not one of its punctuation characters, so that's no. Is C a punctuation character? No. Is the plus sign?
Yep.
Yes, it is. Plus is one of the punctuation characters in ASCII. So it returns an iterator. Careful. Returns an iterator to the first plus character. Returns an iterator to position 7.
Thank you, someone.
So that's find if. You've got its evil twin, find if not. So, find if not. Okay, so what is find if not going to return us here?
The lowercase, the first lowercase.
It's going to return an iterator to the first lowercase letter, which in this case is this E here. So it's an iterator to E in position 1. Now things get a little bit more complicated. We've got a vector of char, really just to show you a different data type. Could have used a string, but we'll use a vector of characters. And we've got vowels A, E, I, O, and U. So now find first of. We're going to search in our string for a vowel. We're going to search within our string and see whether any of the characters match any of these characters in the vowel vector.
Which string are the one?
Yeah, so what we're going to do is we're going to start with H, it's capital H. We're going to say, is H an A? No. Is it E? No. Is it I? No. Is it O? No. Is it U? No. Okay? H does not match any of the vowels. So we're going to move on to E. Do E and A match? No. Do E and E match? Yes, they do. Okay, so we found our first vowel. So it's going to return an iterator to this guy, to the first vowel within our search string. And if you're wondering, yes, we absolutely could have written this using find if. Right? It's just a sort of handy way of doing it without having to wrap things in a lambda or use a function or whatever. We could have used find if to do the same thing. Could have written a function called isVal. We didn't have to. We've got this algorithm that does it for us called find first of. So again, this returns an iterator to E in position 1 because that's the first vowel in our search string.
I suppose with the, just thinking out loud, with the find first of, you may want to find if a set of things or anything in that set of things is in it. Because if you're specifically looking for the E, you're only looking for the one element. Is that right?
Yes. Yeah.
And then the other one is a
It's
set.
looking to see where any of these things occur in this.
Okay, yeah.
So just maybe I missed it. Why did we have the vol dot begin and dot end, whereas in any other situation we just provide one argument?
Because it needs to know how many vowels we have, right? Because
So I couldn't just say vowels and that's it.
no, you have to say vowels dot begin. So at the moment in C++ in the standard library, we always or almost always use iterator pairs. That is, an iterator to the start of the sequence, an iterator to one past the end.
The start is like I was expecting. That's normal, but I'm surprised by the end, the begin and end of the vector vowels.
Okay. What would you expect?
No. I was thinking it would be like, let's say, like in the first character you have the single quotes in space, then you have scope resolution is punked, then scope and is upper.
Yeah.
So just one argument everywhere. So that was my first thought.
Okay, well in this case we're passing a function to act as a predicate. In
Yeah.
this case we're using a function to act as a predicate. In this case we're passing another range. So when we pass a range we have to say what the beginning and the end of that range are.
Okay.
That's almost like a nested for loop, isn't it?
Almost like,
A nested for loop.
yes, in fact that's exactly how it will be done, yeah. It will be done with two nested for
Maybe you
loops.
mentioned it and I missed it, but did you say that you deliberately chose vector to demonstrate that the type is independent?
That is exactly why I didn't use a string here, why I used a vector. Just to show you that the type of this range and the type of this range, they don't have to be related. They both just have to be iterable sequences.
But to make the point, obviously you wouldn't really use a vector, you'd use a string of A,
Yes,
A, I, O, U.
You'd use a string of A, E, I, O, and U.
Would
The
that
fact
work with arrays?
with arrays,
Yeah,
yes,
you
you
pass
could
the person-
you could use an array of char there, That would be another way of doing it.
You can just put the address of the 0th element for begin, for the array.
Yeah.
For the end, you put the last element of the array.
Uh,
The one after.
If you were using a raw C array, yes, or you could use
Yeah.
standard begin and standard end on your raw C array, or much better than that is to use a class called standard array, which is exactly as efficient as raw C arrays, but without any of the downsides. Okay. Finally, we've now got another string hello, which is hello with a capital H. And so this time we're going to call standard search. And what this is going to do is it's going to search for the string hello inside the string hello London, hello C++ London Uni hello. And it's going to return an iterator to the beginning of the first hello that it finds. Now in this case, that's not a particularly difficult thing to do because it's the first 5 characters, right? So it's going to search for this range here, for this guy, as a subsequence of this guy. So it's going to search for hello as a subsequence of hello C++ Uni hello, and it's going to find it right at the beginning. So it's going to return an iterator to position 0. It's going to return the same as string.begin. Because it's found it, it matches, it's right there. So you see the difference now between find first of and search. Right? Search tries to match all of these in order as a subsequence there. Find first of finds the character which matches any of those. And finally we have the incorrectly named find end, which does the same as search, except it effectively searches backwards. So it finds the last match. So this time it's going to look for this substring hello, but it's going to start searching from the back, and it's going to find it right there. So it's going to return you an iterator to this position, the position at which the last match occurs. Yeah?
So why doesn't it look for direction? So or left?
That's effectively what it will do. It's smart enough to actually reverse the search string and check that. Internally, that's exactly what it does. At least for random access role bidirectional ranges.
But it doesn't do it for if you want to like get this big data set of random characters.
Yeah.
And you want to look backwards, if there are backwards words in it.
Yeah.
If you want to do that, then you could use this.
If you want to look for backwards words, well, you could reverse this search string, I guess.
Right, yeah.
There is a function called standard reverse that does exactly that.
Yeah, so search and find them, they seem quite the same. Right?
They are sort of twins of each other, except that search searches forward, and find end searches backwards. That's why I say it shouldn't be called find end. It should be called search end.
It's like a mirror search. Yeah.
It's mirror search. Yeah,
How
exactly.
do you reverse the search one to do the same thing with the one below?
How would you reverse that?
Yeah, I do it.
Not.
You could call standard reverse on your string, call standard reverse on your needle, on the thing you're searching for. Run search, and then flip the answer. It's not. Or you could use reverse iterators even, which is probably how they do it.
What would standard reverse do?
Standard reverse does exactly what you think. It reverses a
It
sequence.
does the opposite of what it's spelled.
So standard reverse, if you called standard reverse on hello.begin, hello.end, then after you did that, your string would contain O-L-L-E capital H.
Yeah, but doesn't do the same thing as the one below.
So I really can't hear you very well.
That doesn't do the same thing as the find end, does it? Because you're looking for O-L-L-E-H. You're not looking for, hello at the end. You're looking for O-L-L-E-H at the end, right? Why you wouldn't put it, would you?
Okay. Well, imagine we were searching for OLLEH and we reversed this guy as well, then that would match it, right? Don't.
If
What?
we reverse that guy, yeah.
Yeah. That was somebody asked how you would.
That would
You
be
search
more work.
instead of
No
find.
one would do that because you need more work. The one.
Yeah, this does it for you.
Does it better.
Does it for you, so you don't have to.
But,
Yeah. Many of the standard algorithms, when we can already see it on this screen. Many of the standard algorithms are sort of, in a sense, redundant because you can implement them with each other. You can always use find if instead of find, right? You just pass a predicate which says, am I equal to that? Right? But find is a convenience. Find if not is kind of redundant because we could use find if and write our own predicate that did the opposite of the thing. But it's there as a convenience. Yeah.
But isn't the whole thing about algorithms is we're trying to find the most efficient way of doing stuff?
Exactly.
You can come up with one solution, he can come up with a solution. We can all come up with solutions.
Yeah.
And we all do the same thing. But when we're talking about efficiency, that's the whole reason we have the standard library, sure.
Yes. Yeah. So they're redundant in the sense that you could use a different algorithm to achieve the same thing, but using find may well turn out to be more efficient than using probably won't actually, but in theory you could have a more efficient implementation than if you just passed a predicate to find if. Okay, let's crack on. These are the finding, the searching operations. Something John was asking about a few moments ago. We're talking about comparisons. So we can compare two ranges and decide some things about them, right? We can decide whether they're equal, whether one range is less than another one. And we can also find the first place at which these ranges differ. And as we just saw with search there, we don't require that the ranges are the same type, only that the elements are comparable. Right, so you can compare a string against a vector of characters. That's fine. All of these algorithms, in fact, most of the search find ones as well, although I didn't say so, we take predicates, optional predicates, allowing us to define what we mean when we say equal, when we say less than. This allows you to do some quite clever things if you're that way inclined. For the most part, though, when we use these, we use the normal meaning of equal. That is, A equals B, as in, what is built into the language. Less than, for ints, has the obvious meaning if one int is less than another. So these comparison functions allow us to compare two ranges. So there's a function called standard equal, and it takes a pair of iterators denoting range 1, a pair of iterators denoting range 2, and it returns true if those ranges are the same length, and if every element in those ranges compares equal. Pretty straightforward. There's what I think is probably the longest named function in the library is lexicographical compare. What is a lexicographic comparison? Well, it just goes through, it's like a phone book ordering, right? It goes through every element and it says, is one of these things less than the other? If it is, okay, then range 1 is less. If the two elements are the same, it goes on to compare the next two elements. It goes on to compare the next two until it finds two that are not the same. So it tells you if one range is less than another range, right? Basically, if you think about how strings would be ordered alphabetically, that's exactly what lexicographical compare does.
So you use it in some sort of dictionary.
You really could, although standard string actually has a built-in less than operator, but this operates on arbitrary ranges. And finally, there's mismatch, which sort of vaguely does the opposite of what equal does, in that it returns a pair of iterators that tells you the point at which the ranges no longer match. So imagine you've got two ranges which have equal prefixes. It'll return you a pair of iterators, one pointing into range 1, one pointing into range 2, that indicate where those ranges start to differ, where they mismatch. So again, let's have a look at an example quickly. Got a string, hello. Got a vector of ints containing characters H, E, L, L, and O, but converted into ints. Right. H is a character, a char, that can be promoted to an integer value. I don't know what the integer value of H is, it doesn't really matter. So now we can check, are these two things equal? Is the standard string hello equal to a vector of ints containing whatever the integer ASCII values are of those characters? Is this true or is this false?
Is it true? Is it ASCII?
It is absolutely true, yes. Yeah.
Doesn't the string also include one character which denotes the stop of the string?
Ah, good question. That is true for string literals, right? So if I didn't have, say, standard string here, if I just said auto, or if I said car star, or car and then put the square brackets at the end, then we would include the what's called the null terminator. In that case, you're correct, they would not be equal. Standard string doesn't include the terminator as part of the string length. So in this case, the people who said true are absolutely correct. So what this is going to do is it's going to compare the first element of these two ranges. It's going to compare the char H with the integer representation.
The null terminator is usually depicted by a /and 0.
That's how you write one if you want to manually put one in a string, yeah. So it's going to compare the char 0 and the integer representation, sorry, the char H, the integer representation of that is going to promote the char to an int. It's going to compare them. They're going to compare equal. It's going to go, okay, those ranges are equal. It's going to compare the E's, going to compare the L's, going to compare the other L's, going to compare the O's. They're all equal. Both ranges are the same size. Both have got 5 elements. Everything's hunky-dory. This is going to return true. So what's interesting here is not only do the two ranges not have to be the same type, we're comparing a string against a vector, but the element types don't have to be the same. The element type here is a char, the element type here is an int. But this works because in C++ we're allowed to compare a char against an int. It'll promote the char into an int.
The values are the same.
Sorry? Because the values are the same, yes.
Character is basically an int, right?
They're compatible, they're convertible.
They-
The maximum we can have is 255. Not 55.
Yeah. Which fits into an int. So
Yeah, but they could be two user types with one convertible to the other.
yes.
Well,
As long as they have an operator equal equals that is comparative, yes.
Free.
Sard, you had your hand up.
I just quickly wanted to check because in the web, it's each element there's an individual int, which is a character.
Yeah.
So
That-
how does it work? Does
that is the
H
same as in a
H
string.
is-
You can-
it's 0 element to 0 element.
Yep.
It's a width extension. So I think a char, really, okay, is just 1 byte, yeah. Whereas an integer is just more bytes, but they're still both just numbers underneath, right? So, you know, the character 0 that you see on the screen is actually number 30. So you can set an int to 30, compare it to the char with the single quotes 0, it would match. Because, sorry,
Yeah,
30
it matches, but what I'm saying is that in vector, each element is separately stored. That's how I see it.
Yeah.
And
It's
then
the same.
it's still contained, I guess.
Internally, string has exactly the same representation as the vector. That is, it is an array of chars.
It just checks element 0 to that.
Yeah.
and 1.
Exactly that. Sorry, you had your hand up at the back.
A char and the int is that if you give like a char to cout will not display the value, will display the letter because it's for
Yeah.
letters. You know that characters are used for letters. So if you pass the int, you display the value. But it's actually a value that char holds. It's like an integer value.
Yeah. Yeah.
ASCII the default type of encoding, or could it even be possible that I mix types of encoding?
That's a good point. This is one of those horrible subjects that goes back to kind of the 1970s when this was first. No, strictly speaking, the encoding doesn't have to be ASCII. However, it doesn't really matter because whatever the value of h is, it doesn't necessarily have to be whatever the ASCII h it will be, but theoretically, according to the standard, it doesn't. But when it promotes to an int, you're guaranteed that this is going to compare equal to the char that contains h. Right, so strictly speaking, it doesn't have to be ASCII, but this will still work even if it's not, even if your user encode your...
But you wouldn't be able to mess around with the code that, let's say you have maybe in one part you need for 16 bytes and in another part you need for 32 bytes?
No, not without using some actual Unicode conversion functions, right? If you're mixing UTF-16, UTF-32, you really want to use Unicode-aware algorithms for that, yeah.
So basically, this comparison is basic. Even if I didn't put the int, they still they'll still compare as ints, won't they? They won't compare as characters.
Char against char, I don't think does any promotion. It just checks whether they're the same byte.
It's just an int, it's just 1 byte. Char is an integer, it's just 1 byte.
No.
We cannot, the maximum we can hold is 255 if it's unsigned. If it's signed, it's 100 negative 128 to 127.
Okay. We got another string now, Jones 1, and his brother, Jones 2, Jones A and Jones B. So we're going to have lexicographical compare, and we're going to pass Jones 1, begin and end, and Jones 2, begin and end. And then just because I'm nasty, we're going to pass a comparator. And this comparator is standard greater. That is, this comparator returns true if one is greater, if the thing on the left is greater than the thing on the right. Right, so the default comparator is standard less. We're reversing that. We're going to use standard greater as a comparator. So what we're going to do is we're going to lexicographically compare Jones A and Jones B. But we're going to say, is Jones A greater than Jones B? If we were to do this in a sort of phone book ordering. So is Jones A greater than Jones B? No. This returns false. If we didn't have this bit at the bottom, if we just use the default comparator of less, it would return true, because Jones A occurs in the alphabet. You know, if you imagine the telephone directory, it occurs before Jones B. But we've used a different comparator. Rather than using less, we're using greater. So in this case, Jones A does not occur before Jones B, so it returns false.
We're not using this match.
Oh, I didn't use Jones A and B. Yes, mismatch. We'll see it in a second, but mismatch would go through all these pairs here, and then it would, up until it got to the end, and then it would return you a pair of iterators, one pointing there and one pointing there. So this time we've got Hello World and Hello C++ London Uni. And now we're going to call standard mismatch. That is, we're going to find the position in these strings at which they are no longer the same. So we're going to begin at the beginning, and we're going to skip over the identical prefixes. So in this case, both strings. It was very clever and used variable names with the same length. It's going to look at the first two elements. Are H and H the same? Yes. Are the E and the E the same? Yes, 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 yes. Space, that's the same character. And it's going to compare capital C with capital W. It's going to say, well, they're not the same. That's where we have our mismatch. Right. So this returns a pair of iterators. The type is actually standard pair. I've named the variable pair here as well. So pair.first, that is the first element. is an iterator into our first string that points to the capital W. And as you might imagine, pair.second points to the capital C character in string 2.
So surely aren't they got to be in this? They'll be different. They'll be different. It'll be the same index, but obviously different memory. Okay.
Yes, and also don't forget that these could be, I happen to have used 2 strings here, but you can use 2 different types of ranges if you want to. You could have used a string and a vector, could have used a string and a list, could have used a...
But the iterator will still be position 2.
Yeah, they'll both point to the same index,
Okay. So
but,
it's really just for
within
derefer-
different
It's
collections.
really just for dereferencing if you want.
Yes, exactly that. And because, you know, mismatch doesn't know, maybe you don't really care about the position in range 1, you only care in the position in range 2. So it gives you both iterators.
So the return type is pair.
The return type is a standard pair of first iterator type, second iterator type. Really going to race through. Yeah.
So in that last one, in lexicographical compare, the predicate is the greater.
Yep.
But okay, it's probably just an example. That's the reason why the braces. There's nothing in between them.
No, so it's a bit technical, but standard greater is actually in a class, not a function. Right. So what we have to do is we have to create an instance of this comparator class. It's a class with an overloaded function call operator. So that's why we have to create this function object.
We couldn't just use like, you know, or single quotes and then you know, chevron like.
No, you can't. No, you have to.
But if you overload it.
But if that's a function, then you need.
Standard greater is not a function. It's a function object.
Sorry.
It's a function object.
Okay, yeah, sorry.
That's a class that overloads the function call operator. This is something that's sort of, it allows you to have stateful predicates, basically. It's a kind of advanced thing. But. Right. I'm going to race through talking about copy if, copy and copy if. So copy is a very useful one that takes a range, takes a pair of iterators, and it copies it into some other sequence denoted by a start and output iterator. Takes the input range, copies it into an output range. Really simple thing, you think. You could do this in a for loop in literally 2 or 3 lines. Why bother? Why does standard copy exist? Standard copy exists because it's optimized to hell. Right? If you use compatible iterator types, element types, this is like super duper optimized. It's going to call mem copy. It's going to, you know, use the really most efficient possible way of doing it. Copy if is really good.
Where's the toilet?
Go outside to the door and through the door you enter. Go past the lifts and on the left.
So we'll go out completely out
Yeah.
of the building.
By the
No,
lift.
it's this floor. It's on this floor. Just down, take left. So you go to the past the elevators, and it's on your left.
So copy, if you want to copy one sequence into another, standard copy is really super duper optimized. You will not be able to beat it. But it's also, there's another little trick that you can do with standard copy, which is to print a sequence. If you try to just send a vector to standard out, you'll have realized it doesn't work. But we can print every element of a sequence using copy and this thing called OStream iterator. OStream takes a standard output stream like standard cout or like a file stream that usually used with cout, and it wraps it in an iterator so that we can use it with standard algorithms. It's an output stream iterator. And so we can use copy, we can copy every element of a vector, say, into the OStream iterator, and what that will do is it will pass every element to cout, and it will print the vector. You'll see an example of that on the next page. Copy if is very, very similar to copy, but takes a unary predicate. It checks every element of the input range against the predicates, and it only copies those things for which the given predicate returns true. So in this case, we need the algorithm header for copy, we need IOStream because we're going to be printing something, and we need this iterator header as well because that's what gives us this OStream iterator adapter. So I've got a vector of ints 1 to 10, and we're going to copy all the elements in the vector from begin to end, and we're going to copy them into this thing called an OStream iterator. And we've initialized our OStream iterator with cout because that's the stream we want to output to. And then we've signified we want to separate the elements with a space. This second parameter is optional, it's the separator. We want to use a space. So this prints every element of the vec separated by a space. So it's going to print 1 space, 2 space, 3 space, etc. Right. Again, you could do this with a for loop, range for loop, and just do cout, arrow, arrow, I if you wanted to. But hey, standard copy exists. And this is a neat little trick that you'll sometimes see whenever we use it. Show you another little handy trick. This time we've got another vector of ints. I've called it out, and it's empty. It's got nothing in it. And I've written a predicate called isEven. Takes an int, returns whether an int is even or not. Does the remainder after division by 2. If the remainder after division by 2 is 0, it's an even number. Dear oh dear me. Try to do this properly and you mess up. Okay, so now we're going to call copy if. Again, we're going to pass the whole vector. And then we're going to use another one of these iterator adapters called back inserter. Back inserter is actually a function that creates an iterator for you. And we're going to pass it our vector out. And what this is going to do is every time we write to the iterator, it's going to call out.pushback. It's going to insert it into the back, insert the value into the back of our vector. And this is copy if, so it takes a predicate, and it's going to copy, it's going to use our isEven predicate, so it's only going to copy those values for which the predicate returns true. So after running this, out contains 2, 4, 6, 8, and 10. Contains the even elements of our input. It applies a predicate to every element. For those which return true, it copies them into the iterator, the output iterator, that's this guy. In this case, this is an iterator adapter which calls pushback, so it actually expands the output vector to accommodate new things. Pretty handy. I told you this was rapid fire, right? Remove. Now, if there were a prize for the most unhelpfully named algorithm in the whole library, remove would be that guy. So remove, it takes a range, it takes a value, and it looks for every occurrence of that value in the range and removes it from the range. Except that remove doesn't actually remove it from the vector, or from the list, or from the string, or whatever container you're using. Instead, what it does is it moves it to the back and shifts all the other elements around. And then it returns you an iterator to the new end of the container. doesn't actually shrink the container, doesn't physically remove them from the vector. It just shifts them around. And so that all the elements you don't care about, all the ones you want removed, are at the back, and the things you do care about are between the start and whatever iterator it returns to you.
So it should be called shift.
I'm not sure about shift. I think we could probably come up.
Rearrange.
We could probably come up with a better name than remove, but I can't think of one off the top of my head. But the actual, this is the key point about remove. The actual container is still the same size, right? We haven't physically shrunk the container or anything like that. We've just moved the elements around.
How old is this?
This was about 94. They came up with this.
This is not a copy, this is the original.
Yes, this modifies the container by shifting the elements. There is a remove copy function actually. So in order to actually delete the elements, we have to use a member function on the container called erase. That actually erases the elements. And using erase, using standard remove and standard along with the container's erase method is really common, even has a name. People call it the erase remove idiom. So let me show you that.
Doesn't it wouldn't it just be the same as this? Because you pushed all the unwanted things to the end, you can just make a copy of that, put in an empty array.
You could do that, but if you imagine you've got 10 million things, you want to get rid of half of them. You don't want to copy. You don't want to copy another vector with millions of things in it. So here we've got a vec 1, 1, 1, 2, 3, 4, 5. And now we're calling standard remove. Vec.begin, vec.end. We want to remove the value 1. So what this is going to do, it's going to remove all of these guys. They don't necessarily have to be in order. They could be other ones sprinkled throughout the container. But in this case, they're all together at the beginning. And it's going to shift all those guys to the back and move everyone else forward. So it's now going to contain, the vector is now going to contain 2, 3, 4, 5. And the return value of standard remove is an iterator. And it points to the first occurrence of 1. Points to the start of the removed elements.
Or to the space before 1.
If you prefer to.
Remember the example you said.
So what this means is that if we were to now go and call another algorithm, we could pass it vec.begin and it. And it would only, that other algorithm, sort or whatever it may be, would only operate on these elements here, the ones we care about. And it effectively allows us to ignore these other elements that we don't care about because we've removed them from the range. So you can think about the iterator as the new end of the container. We can now use that as the past the end iterator to pass to other algorithms.
So if we put this to let's say sort, should we say vec.begin, comma, it.end?
No, just it. It is an iterator, yeah.
But shouldn't we then add it minus 1?
No, because sort expects a past the end iterator. And it points there, which is 1 past the end of the range that we actually care about. We care about 2, 3, 4, and 5.
Oh, okay, so it will point, okay, I understand, so it will point to the space between 5 and 1.
Yeah.
You do that with the standard vector of strings, and say, if you did hello, hello, hello.
Yes, yeah,
well, you.
absolutely. So in order to actually erase the elements from the vector, we have to call a method, call a member function on the vector itself. So we call vec.erase.
Sorry, I don't see how, if the remove algorithm takes the first element in the vector and puts it at the back.
No, it just, in this case, it so happened that the elements to remove were at the beginning these ones could be sprinkled anywhere through the vector, and it would move them all to the back. It just so happened that in my example I put them at the beginning, but that's just chance. Imagine that if it was
for an element of value 1, whatever that is, and then puts it all at the back.
puts all the ones at the back, yes.
What's the difference between erase and
Clear erases everything. Clear is the same as doing erase begin end.
okay, yeah.
Clear removes everything from the vector.
So it's exactly the same.
Yeah, it does exactly the same as.
Here it just doesn't take a begin end.
Yeah.
It doesn't take any arguments, so it's faster to type.
So vector erase, there are actually two overloads of erase. One just takes a single iterator and says delete, erase the thing at this position. Here we're using the form that takes two iterators, and we're saying erase everything beginning at this point up to but not including this point. So we want to erase, physically remove from the vector, shrink the vector so that it no longer contains everything from here up to here. That is, it's going to remove these three elements. So vec, after this call to erase, vec now contains 2, 3, 4, and 5. So doing these things together, calling standard remove, and then passing that argument to erase, really common to do them all together in one step. We call it the erase remove idiom. So this time with a string, got A, B, C, D, E, F, G, A, C, E, and G capitals, the other ones are lowercase. So we're going to call remove if, which is, as you might have guessed by now, removes brother, that takes a predicate instead of a value. And we're going to look at all the elements in the string from begin to end, and we're going to use this predicate, is lower. And what this is going to do is going to shift around the elements of the string so that all the capital letters are at the front, all the lowercase letters are at the back, and then it's going to return an iterator to the start of the lowercase letters, the things for which the predicate returned false. And then we're going to take the iterator that remove if gives us, and we're going to pass it straight into string.erase. And we're going to erase from the string everything between this guy and the end of the string. So put it all together, and this is going to erase from the string all of the lowercase letters. It's going to remove if things that is lower, and then it's going to actually physically erase them. So after we do this, we're only left with A, C, E, and G. If there's one takeaway from this, just remember standard remove doesn't actually remove anything. It just rearranges things. It returns you the new end of the container. Just a second, sorry. Yeah. Sorry? I have, thank you. No. Okay, I was going to tell you about a little bit more, but we've only got a couple of minutes. So I'll talk about transform, which is, in some ways, the most general algorithm in the whole library. Transform. Many of the other algorithms can be written in terms of transform if you have enough patience. It's one of the most general and one of the most useful. So it takes an input range and a function and an output range, and it applies the function you give it, it applies that to every element of your input range and places the result in the output range. Right? apply some function to every element of my container, is what transform does. This is very common in functional languages. It's often called an operation called map. So if you're familiar with, Pascal or something like that, in C++ it's called transform. There's also a binary transform, which takes two input ranges and takes every element from both ranges, passes them to a binary function, and places the result in some other range. That says binary predicate. It shouldn't. It should say binary function because I'm silly. All right. Final set of examples. So we've got a string called in and an empty string called out. And what we want to do is to make out an uppercase string. That is, take hello, transform all the letters to uppercase, and put the result into out. Again, you probably think if I'd set you this task a few weeks ago, you might think, oh, well, I'll write a for loop and, push back on the string, or plus equals, whichever way you'd want to do it. We can do it in one go, in one line, with standard transform. So we take every element in our input string, in.begin up to in.end. We insert into this guy out using this back inserter wrapper that calls pushback. And so for every element in this string, we call this standard toUpper function, which, as you can probably guess, transforms the string to uppercase. So it transfers the character to uppercase. So out now contains hello in capital letters, a very shouty greeting. Yeah?
I do have a question. Why do you use the scope resolution operator according to upper?
Yeah, this is, Tom asked this before, it's because there is a second version of standard toUpper that's in the standard namespace that takes a second parameter that's locale. And if you put standard toUpper in there, it's got two functions, two overloaded functions, and so it doesn't know which one you want to call. So it's an error. So this just makes sure you call the C library version.
So you do ADL.
Yeah.
Don't look up.
So in this case, we're transforming and we're putting the result into a different range. We don't have to do that. We can actually overlap the input and output ranges. So this time I've got a vector of ints, 1, 2, 3, 4, 5. And I've got this operation, this function I want to apply called square, which squares an integer, multiplies it by itself. So I'm going to call transform again. I'm going to take everything from ints.begin into ints.end. I'm going to place the result in ints.begin. And the operation I'm going to apply is square. So for every element in here, I'm going to replace it with its square. I'm going to square every element. So after calling this, ints now contains 1, 4, 9, 16, 25, the squares of those 5 numbers. Finally, just to show you binary transform, we've got 2 vectors in 1 and in 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. We've got an output vector which I've just initialized with 5 zeros. So now I'm calling binary transform, so it takes 2 ranges. That is range 1 from begin to end. range 2 from begin to end. I'm going to place the results in this guy. Now this guy, I've made sure he has enough space. I've made sure that he has 5 places, so I don't need to use back insert. And the operation I'm going to apply is this standard library function object multiplies. And what that's going to do, standard multiplies takes 2 arguments and it returns you, then multiply together. So what this is going to do is going to take 1 and 5 and multiply them together, which is 5, and it's going to place that in out.begin. It's going to advance everything one place. It's going to take 2 and 4, multiply them together, that's 8. It's going to place that in vec.begin. And so on and so on and so on.
What happens if one of them is larger? Does it ignore the one that's long?
In this case, it'll stop as soon as it's reached the the end of the smallest range. Yeah. So out now contains 5, 8, 9, 8, and 5, which, if my maths is right, is these 2 things multiplied together in each case.
So excuse me, I missed it. What's the third argument in the transform? No, in the one,
Yeah.
the easy one.
The unary transform, this is, the third argument is where to place the result. It's the beginning of an output range.
Okay.
Well, I had one more thing about numeric algorithms, but it doesn't really matter. You don't need to know about iota and accumulate, right? For we do have half an hour remaining.
27 minutes.
Yes.
It's okay, we're not on the clock.
But that's it. I'll leave those, when I put the slides up, I'll leave those last 2 slides in if you want to go and have a look at clever things you can do with accumulate. But that's it for our standard library algorithms and containers module. 7 long weeks of it. So next week, as Tom mentioned, we don't have a class. We're all going to be at C++ on C. This conference happening at Folkestone. The week after will be, we don't know where we are yet, do we?
Probably here. Come on, do it.
And we'll be talking about object-oriented programming. And probably to your relief, I won't be doing it. It'll be Ollie who's going to teach you for a few weeks. So it'll be a nice few...
Paradigms, isn't it?
Object-oriented paradigms, yeah.
Programming.
So I will be here, but I'll be sitting there and he'll be standing here. So it'll be a nice few weeks off for me. But that's it for now, from me, for a few weeks. So thank you all very much. And as a parting gesture, have a little quiz about standard library. There's standard library containers and algorithms, or modules and algorithms, as it says there for some reason. So if you go...
yes, sorry, it should be if the test is on the correct thing. I don't know why I wrote modules shortly.
So if you go to this URL, you'll find it. We'll send you to a Google form. Those who've done this, been here before, will have done this a few times already, right? So if you put your email address in, we promise not to spam you, but it'll allow us to send your mark back to you, tell you how you did. And then, well, I guess it's going to be a couple of weeks before we can go over the answers.
It's not going to work because our security software we have here has blocked bit.do. Let me use a
One moment.
Google form, which is not easy to type. Who is on the CPP Lang Slack?
Me.
Okay, I will link it there. That's a lot easier than you can just click on it. But in the meantime, I will also shorten it. Tristan, give this a shot, please. Tom will complete it. Okay, it's linked in the CPP Lang Slack. Tristan, go ahead and pop on the slide. It's not as short as I'd like, but the best I can do. Hopefully that works. Try it. Just click on it.
Yeah, I want to sort of copy and paste on video.
So if you're watching at home, you can go to that first URL. For the people who are here, this is blocked by the security software in this office. So you can try and type that, or you can just log into the Slack, which I've been nagging you about for months. So if you're not on it, it's your own fault. It is on Slack. So have a go at that. If you have any problems accessing it, put your hand up.
Sorry, this side is blocked. Have you not posted it again?
Since like
Slide.
CGP, nothing new. Yeah, it's not the easiest thing to type.
Ollie, when you have the multiple choice, that means you won't expect always more than one.
So depends on the question. So
example,
I would
so-
recommend you to look at the number of points that you get for a given question. That'll give you a rough idea of what's expected from those ones. If you are required to write code, then you can do it in C-line or whatever else if you want. If you are required to read code and figure out what it does or what it means, then do not do that. Obviously, it's cheating.
Sorry, what did you say?
If you are writing some code to answer a question, you don't have to do it inside Google Forms. You're free to do it wherever. If you're reading code I have written for you to evaluate, then don't copy it. It's cheating. That's pretty much it.
Copy and change
And pay attention to the points you get for the question. If you're pretty good idea of the difficulty or what you need to answer. So if it's multiple choice, there's 2 points. You can tell what it's to do very well. And don't guess at questions. Nobody's getting anything other than a gauge of their understanding. It's good for us and good for you. If you don't know it, just don't answer it.
Could be a very short test.
I mean,
Yeah, no,
if that's how it is, that's how it is. It's just-
You get to our chat. So like, how do you get to our chat? So,
I don't know. I just go there. I ages ago and I managed to get there and it just goes there automatically.
yeah.
Access to the slide.
So if you go to channel plus
Anyone needs clarification on questions, that's fine. Clarifying if you're not sure.
Yeah.
Sorry. Are you allowed to cheat? No, you can just Google it and find the answer.
Yeah, I've got a quick question.
bearing in mind I haven't seen the test.
Yeah, no. That's right.
You want to leave that?
Is this
Well, it doesn't
say the if statement doesn't.
the if statement doesn't actually need to have curly braces.
But it doesn't need to be on the same line.
It doesn't matter.
Oh, that makes sense.
That's exactly right. I asked you, do you make it do star attack?
So these guys here, they just
I relocated.
Yeah, we're very grateful to Minecast for not only hosting us but providing some refreshments. It's very generous of them.
you steal it from
No, I don't want to get fired.
you pay the other two. Or you don't pick up your games.
Sometimes
Because the place in Diablo 2 called Tristan. You play Diablo 2, right? There's a place in there called Tristan, right? Diablo 2. You don't know.
Classic name.
It is a They're gonna remake it over here. Start with GP. Start. Yeah, I know. But for StarCraft 1, right? They're gonna do the same with Warcraft and Diablo 2. Sorry.
People were quite upset about the announcement of the mobile version of Diablo.
They announced
Ollie. Sorry. Quick question. Is this a tricky thing you're trying to do, or is this the right path?
That's a typo. Yeah, okay, sorry. There is a typo on one of the questions where I've written vector arrays I accidentally used a colon at the end instead of a semicolon. Do not treat that as a colon. Assume it is a semicolon.
This way is the same as the photos. This one goes up to that. That's the what we're looking at when you say that. It's going to show you how to do this. It's going to problem solve for you. So show you how to do it. But this book teaches a problem. Teaches a problem. I had an engine for pretty much everything that load sprites. But in a 2D game, that's all you need. You just need to load sprites. If you have like good engine to load sprites, you can load sprites, which is like 2D game is also very yeah, to the engines, yeah. I use that to load the sprites. That was okay. Not to these. That's why people should, especially independent developers, they should think because you can make money and then you can move to the. That's what not people do. If you make something good, then people will enjoy it to be. But it's not. It's not it's just a Google search of what. Yeah, you can just copy if you want. It's better to read them and try to see how it works, how it works.
Yeah, you didn't know when I was
You know it in the future. Improve because everything you see, there's something enough time. They could sometimes talk together and work together. They can do that. Once you can make something, it's really good to solve. You can make something to do small team, 3 programs, 1 or 2, 4, maybe one does not focus on it. It shouldn't be people, it should be people to be able to yeah, I think that's for 2 so yeah, you just need that function that puts your sound into this space. X, Y. So it's going to do this thing, so the sound file. It's going to make it sound like it came from X, Y. So X, Y is the location of the shoot. So it's not too much to learn because it's 2D. So when it's 3D, it's a bit more complicated, but X, Y, Z. So it's not that. The sound is not the sound program is not difficult. It's difficult. It's the AI, 3D graphics, mathematics and great sound as well, 3D sound, because of like a sound. Used to like make the sound like a sound like it came from where my location was to the AI's location. So when you're here, the AI is on the left. You have to make it sound like the AI is on the left. You have to make the solution that it's going to be on the left. And to do that, have the sound like again, just like with that weird episode. With the engine. I use the engine. Don't get me wrong, I did use the engine for everything. That's why I went fast. So I made a partial engine. It could be used to upload sprites. Again, it's like a copy. One of my friends was modeling for me. And he could basically create models and then you would load them in my game today. Load the models into my real engine. It will show with the hardware image. It's just like the one of the place sprites. You can keep them like numbers, faster, slower. It was basically so C is what achieved. Again, like for instance, so you can one time across the numbers, the other one's moving to the first, the other one's so those are called frames, and you get display them split. Going around, so if you're playing the key W, then that's the move left, then display jump, shoot something, and this something comes out of you, it's like a bullet, its own direction. The velocity also, I'm thinking sorry, when I said I use the engine, I didn't use the engine, I used the library to do that. The engine is not made, I use it. If I use if I wanted to make a 3D engine, I'll use the 3D so yeah, but they are not engines, they are programs. You just use the code to set the standard. They wrote it. They wrote the code, you just use the shortcuts. Shortcuts. You don't have to write the code. Just use the shortcut function. Are you asking if I go through the library to look at things I've done? I try to make it myself. Yeah, I can most of the time. But it's not. Only when I get stuck. Just get confused about it. And then when I get there, it's something simple. It's difficult as my approach. Solving a problem. That's right. When we were in, but before that, I would put like CR, I say please enter my space hotspot. Because if you do that, it's just going to bring a black screen. And then the user's not going to know what to store to write. But because you know what you're doing, it's not problem. Someone else will use it.
You need to. Yeah, that's right.
But I don't think I can put STD. STD, that's not a problem with big projects. If you put STD, STD you can put in the big function. So you don't have to put it globally. The problem is when you put it globally. But when you use it inside the main function, it's only the function calls. So you do it inside the class, it's only going to be visible. So that's so if you're careful about the style, just don't do it in your block. I do it wrong. Yes, other people be but it's C++. It's not some other language. It's still
That's the spin. That's only spin.
so unless you name your variables like random letters and numbers, it's not going to be someone. Only if you name it as rubbish. If you name your variables properly, really good. I mean, I don't even need to look at the code. I understand what's happening just by looking at it. And I made the mod for this game, and actually, this game is written in C++. Superpower is called the game, and it was quite a good game. It's quite a good game. No, it's 3D. And you're like, well, you can take control of the superpower, so you can take North Korea, and you can just kill everyone. And the game wasn't like, the game did get updated. So I just add some stuff to it. And it's really C++. It's handing out the classes now. I really need to just build some classes. So it's a really nice game. So if you want to be like a superpower, you can like do basically the superpowers. You create terrorism in other countries. Like basically you can create spies and send them to other countries and they can do terrorism. So it's like a real life. But this game is cool.
Yeah.
It's an old game, but it's really nice. It's quite nice. It's really, it's not like a game that much. But most of the time you can look at it as much. But it's not about what's after, it's about the you know, the mechanics and the internal mechanics.
That's the secret.
The brain,
It's relying on
demonstrates it's not about it's about the game. Yes, yes, and what you can do, how you can do it. You know, improving your infrastructure, improving your economy, invading other countries, doing the lines of Burma. It's really, really good. And it's the code, it's not that complicated, but actually it becomes better. The only thing that puzzled me a bit was the graphics part, because I know nothing about graphics. So the graphics part of the game, it's quite, you know, I tried to like make it up for it to be something, but it wasn't something. Maybe there's something that was to be written.
What I'm saying is,
You can ask those people.
saying, is that so? Is it
No, but I think one of the one of matrix. I don't know about all the other examples. So nothing. I can touch a lot. Keeps a lot. Fix the AI. The next test. Improve the AI. So you could create this. Well, I don't. Yes, I could give the AI borrow money or give it just to one line so it's a bit bigger army. I could do a lot of things, you know. Anything that comes to that is nothing but Bitcoin. You don't lose much. It's also going to be it's going but you don't do it until you reach the game. You don't do it. Well, you do it for the game. So, if you like, you do a pick. So you do it for the game. I guess you kind of do it for the people as well because there's no one. It's like your game is a reason. So you do it for the community, but not the first time. So you do it for the game. So that's what then you share with the community. And then kind of do it for the community as well. You want to create the game further or improve the game. Because people still play the game.
It's a tangible, that's a tangible expense, it's a tangible thing.
But
The same way that
I think you learn from it as well.
you tangibly have to go to the end
Stuff
of the
that
day.
you know. And a lot of it's advice for the UX for pretty much everything. So, even if you do games, what I learned a lot, and what I learned by actually this game is so scope is that the way the grab and cop works, I could just read it to look at the space of the way operations. You just read the value, and now it's something they are the whole approaches, they are really, really good at making programs just by making very data.
Producing that. That's it. So that's the reason. So takeaway.
Because without that,
Value isn't
if you don't have that, then it's good to make
thing
it
itself.
a little because then you have to calculate the perception. So yes, we kept it because if you do it like that, you don't have to comment on it afterwards because it's like a comment, right? It's a good name of a very good thing, like a public comment. So it saves you from spending a lot of time on the things of the program. So you still have question, just not so much.
That's an archaic term.
Not anymore, it's not on there.
It's an archaic term. It used to be. No, it is still on there. No, it is still on there. It's still on there. It is 100% still on there. Yes, you are correct.
You're in school.
Yes, they can. Yes, they can.
School is easy. School is nothing.
Oh, yeah. You know, you wouldn't be screwed.
Just, you know,
Yes, they have.
then there's
Yes, they have. John Sargent,
jump
John
on
Sargent.
Just get better and try something.
Sorry.
If you touch a regulatory library, the most hard have to like they are to the library. The code lets you display the sprites or draw the sprites. So you're not going to need a lot more than that unless you can want to make sound. You probably make something that's beautiful or like lighting, so pictures. We'll give it back. No, you use that sample to give some sprite.
So I asked for your emails because I have to manually review these. Some of the questions are probably looking at the code and obviously if you want a response, which I assume you do, you need to give me your email. You don't do anything with your email. Which is not one of them.
I apologize. It takes time because I have to do the graph
Sterling silver. Sterling.
yeah, it's true.
So now it's just be a currency and it's something
I don't want to use my language, I don't want to use their scripting language. Because they use C++,
Gordon Brown.
Unreal might be better.
Ollie,
Yes.
are you able to check if you got my answer? Because something funny has happened and I have no idea whether it works.
Yeah.
I'm worried that this kind of trick or something. To get it was buy it or something, to get the promotion.
Well, this is what they say.
7 responses so far. How many?
Do you have my one?
That's not enough.
Do I have yours? What email? Your email?
My normal, yeah.
I'll probably choose Unreal Engine. So I could go into the
Okay.
Unreal Engine code, use the C++,
Yeah, you go to the top.
go into it.
If I had the staff instead of thingy, and it showed chimney, so I clicked to it, so it selected. Oh, I'm sorry.
Icons. You create them. It'll be like
No, it showed the captcha and then
this is
it
the program
disappeared.
you create to make those. It's a bit like Reason. Basically, you can see the stuff and you can interact with it with the mouse.
If I go to Ludo, I need to be let back in.
Yes.
Unreal Engine is a bit like that, so you can do it like that with Unreal Engine, which is easy.
I don't know what you're saying there.
Just,
Okay, I'll print it
I
out.
didn't make it. Hold on.
I'll print it out for you.
Hold on. Just be sure you have this.
I wouldn't get the captcha, yes, without if I was hitting something.
Okay, how many people have finished? Probably a better question, how many people are still going?
I mean, just keep that tab open. Make it and doing your tab.
Stuff like this, you have to change this so you're making a
Last
space.
question.
5 more minutes. 5 more minutes. Who's still going?
So we did that thing in place.
Still going. 5 more minutes.
Yeah.
Why do we need to use templates?
It's true.
What's the test? Can do it later. You can do that at home. It's definitely a good way to learn the language. Do it at home. You know what? I think that
Challenge.
That means that
I don't know, we could make I can suggest just grab the machine.
You know, especially smart people, they work better. Because others,
submit it.
you don't get confused.
Let me submit it. working on last week.
Because when I did the homework, the templates were easy with that.
What's he saying? Template function. It's the exact thing he did there.
Actually, the one thing that gets me is the.
I mean, you could do it like
It
super
returns a
simple.
copy of the
Yeah,
tab.
I'll probably miss loads of stuff and got loads
Some of the stuff I really want
Let's
to know.
modify the container that's coming in.
Do you want to
To modify that.
Which one is
Your
yours?
return
The black
the
one.
original.
So was he asking just to copy that into and I use that on
No, you could do it with the iterators. The thing is, I thought with templates, you shouldn't use, for your return type in templates, you shouldn't use order. That's what I
So
remember.
what you think?
Don't you just return the T? Template, return the template
T. You have a new cheat.
Sorry, I shouldn't have said that. You have submitted it, haven't you?
Yes.
Okay, bit of an extended session to make up for a delayed start, so you all had a bit longer on the quiz. Just a reminder, no class next week because we're all going to the seaside. And the week after, Ollie will be teaching us all about object-oriented paradigms, object-oriented programming in C++. So watch your email, watch Slack. We'll let you know where it is, most likely here, but we'll get that confirmed for you. And thank you all for coming, and see you in 2 weeks' time. Cheers.
Thank you very much.
And as usual, we will be going.